So let's see how to draw Lewis-Dot structures for some of the homework problems that were assigned. So first thing we need to know is how to write out the formula. We know that hydrobromic acid has the formula HBr. Now, so let's look at the two atoms involved. It's hydrogen and bromine. So in order to figure out the number of valence electrons that hydrogen has, I will look at the periodic table and I know hydrogen has one valence electron. I look up bromine and I know bromine has 7 valence electrons. So I now go on and draw hydrogen with one dot and bromine has 7 different valence electrons. So now there are two singles, one on bromine atom and one on hydrogen. So these two will pair up and there is a single bond between hydrogen and bromine. Now there is only one bond and it can only be a straight line, therefore the shape is linear. Next we write out the formula for water. Now I will look up the number of valence electrons. For hydrogen is 1 and for oxygen is 6. Oxygen I know has 6 valence electrons, therefore needs 2 more. Or in other words, oxygen can bond twice. Hydrogen only has 1 valence electron and hydrogen will only bond once. So therefore I choose to put oxygen in the middle and I will show the number of valence electrons around oxygen. Now oxygen has 6, therefore it can bond with 2 more. These are the two sides which has a single dot each. These dots need to be paired up. Therefore, I will write hydrogen with a single electron on each side that there is a single dot and I will pair up my singles. So if you now look at the structure of water, these two pairs are known as bond pairs and these two pairs are known as lone pairs because they are not bonded on the other side to any other atom. Now, whenever this oxygen atom is supposed to be the central atom, it's the atom in the middle. Whenever the atom in the middle has lone pairs, it will push the bond pairs down and make it angular or bent. Therefore, the name of this structure is bent. Now, going back to polarity, we can also predict polarity of the molecules that we have written so far. Hydrogen and bromine are two different atoms, so therefore this molecule will be polar. Now, anytime the central atom has lone pairs, the molecule automatically will be polar. In fact, all bent structures are always polar. Now, we have a little assignment here. We have to write out the name. So the name of this compound is sulfur dichloride. Now, sulfur from the periodic table, if you move up, has 6 valence electrons and chlorine has 7 valence electrons. So now sulfur needs 2 more or can make 2 bonds. Chlorine needs 1 more and can make only 1 bond. So the one that makes more number of bonds will go in the middle. Sulfur will be the atom in the middle. Now sulfur has 6 valence electrons. So I'll fill out the Lewis-Dot structures for sulfur. Now there are 2 unshared electrons. These will like to bond. And we have a total of 2 chlorine atoms. So I'll put my chlorine atom one on each side. Now chlorine has 7 valence electrons and I will choose to show my single on the side that can pair up with sulfur. The other chlorine also has 7 valence electrons and it will pair up like that. Now this shape, if you look, is very similar to water. There is a central atom, there are 2 bond pairs and 2 lone pairs. So this molecule also will have a bent structure and it will be a polar molecule. Now, Let's write out the formula for phosphorus trifluoride. Phosphorus trifluoride is PF3. Now, if you go up to the periodic table, phosphorus has 5 valence electrons and fluorine has 7 valence electrons. Phosphorus has 5, fluorine has 7. Phosphorus needs 3 more, fluorine needs 1 more. So phosphorus can make 3 bonds, fluorine can only make 1 more bond. Therefore, phosphorus can make more number of bonds and will be the atom in the middle. Now, phosphorus has 5 valence electrons. And we notice that there are 3 single electrons and there are 3 fluorine atoms. So, each of the fluorine atoms will occupy each one of those places where there is a single electron, and the single electrons on fluorine will pair up with the single electrons on phosphorus. So now if you look at this molecule, there are 3 bond pairs and there is a central atom with 1 lone pair. If there are 3, the shape could be either trigonal planar or trigonal pyramidal. How do you decide if it's trigonal planar or pyramidal? We now notice the lone pair and it's going to push the bond pairs down. So the shape of this molecule is trigonal pyramidal. And all trigonal pyramid shapes are always polar due to the lone pair of electrons on the central atom. Now the name of this compound is carbon tetrabromide. So there is 1 carbon and 4 bromine atoms. Again, looking at the periodic table, carbon has 4 valence electrons, bromine has 7 valence electrons. So it's 4 and 7. Carbon needs 4 more, bromine needs 1 more. So carbon can make 4 bonds. So carbon will be in the middle and bromine will be in each of the corners. So I draw carbon with my 4 valence electrons, 4 dots on the 4 sides, and I will add my bromine with 7 electrons, 1 being single on bromine, to each of the sides of carbon, and the single on bromine will pair up with the single on carbon, and we have a shape in which we have 4 bromine atoms surrounding the central carbon atom. Now, if you look at the central atom, in this case carbon, it has 4 bond pairs surrounding it. There are no lone pairs, only 4 bond pairs. So anytime it's 4, the shape is tetrahedral, and all 4 bromine atoms are the same, so the molecule is going to be non-polar. The name of this molecule, the 6th example, is nitrogen trichloride. And now nitrogen, if you look up on the periodic table, has 5 valence electrons, chlorine has 7. Nitrogen needs 3 more, chlorine needs 1 more. Nitrogen can make 3 bonds or more bonds than chlorine, so nitrogen is the atom in the middle. And it has 5 valence electrons, it has 3 single dots. These 3 single dots need to get paired up. There are a total of 3 chlorine atoms. Each chlorine atom will occupy each of those places where nitrogen has a single dot, and the single on chlorine will pair up with the single on nitrogen, and that's the shape of the molecule. Now, that's the Lewis dot structure of the molecule. Now, in order to determine the shape, if you look at the central atom, in this case nitrogen, it has 3 bond pairs, but there is also a lone pair. So what will the lone pair do to the bond pairs? Push them down. So instead of a trigonal planar, this molecule will be a trigonal pyramidal shape, and any molecule in which the central atom has a lone pair will be a polar molecule. Now, If you look at iodine, you do not write it as I, you write it as I2. The reason are there are 7 elements that are diatomic, and we have this in our previous notes page. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen are the 7 diatomic elements, which means you do not write I, you write I2. Now each iodine has 7 valence electrons. So each iodine has 7 valence electrons, and there is a single electron on each iodine that is not paired, and so the singles will pair up, and there is only one single bond, and therefore the shape has to be linear. The atoms on the two sides are the same, therefore it's going to be non-polar. Let's do some of the examples on the back. Let's do dichloro-difluoromethane. Again, carbon has 4 valence electrons, fluorine and chlorine each have 7. So carbon will be the atom in the middle because it can make the most number of bonds. Now there are 2 chlorines and 2 fluorines. Each chlorine and each fluorine will occupy the 4 corners of carbon and pair up with them. That will be a fluorine atom, and it will pair up, and that will be another fluorine atom, and that will also pair up. Now, if you look at the central atom, it has 4 bond pairs and no lone pairs. Anytime it's 4, the shape is tetrahedral. Now, in order to determine polarity, anytime all 4 atoms are not the same and they are different, the molecule will automatically be polar. Now, the name of this molecule is just oxygen. It's a diatomic element. Oxygen has 6 valence electrons. Now, oxygen has 2 that would like to get paired up. So, each oxygen has 2. In order to draw a clean structure, we move up one of the singles to the middle so that it can pair up with the other oxygen, and it looks like a clean double bond, and we don't have bonds that are longer and shorter from each other because that's incorrect. So there are 2 bonds, but they're in the same direction. For considering shapes, we'll consider them to be just in one direction or just as a single bond, and therefore single or straight, and the shape is linear. It's 2 oxygen atoms on the same side, so it's going to be non-polar in its polarity. Now, if you look at formaldehyde, carbon has 4, hydrogen has 1, oxygen has 6 valence electrons. Carbon can make the most number of bonds, so it will go to the middle, and it has 4 dots. I see that there are 2 hydrogens, so each hydrogen will go to each of the sides and pair up. Now, oxygen has 6 valence electrons, and like we did for the previous one, I like to pair up the 2 singles on the same side. I'm going to get rid of this one on carbon and move it to the middle so that I can make a double bond between carbon and oxygen. Now, in order to predict the shape of the molecule, we have bonds that extend out in 3 different directions. There is no lone pair on the central carbon atom. Therefore, the shape of the molecule will be trigonal planar, and the polarity, there are 2 hydrogens on 2 sides and there is oxygen. They are not all the same, so the molecule will be polar. If you look at carbon dioxide, the formula is CO2. Again, carbon has 4, each oxygen has 6. Carbon can make more number of bonds, so carbon will be in the middle. Now, carbon makes 4, and there is a single dot on each side for carbon. But in order to draw shapes that look clean, you will move the 2 bonds, 2 lone pairs on the same side of carbon so that they can bond up with the 2 on oxygen. You can practice, and then you can draw a final clean structure which will look like this. In order to predict shapes, we have bonds that are extending in 2 different directions. There is no lone pair, so this will be a 3-atom linear molecule. Even if you write linear, that's fine. You don't have to mention 3 atoms. This is again oxygen and oxygen on either side of carbon. The atoms are the same, so this molecule is going to be non-polar. So if you look at HCN, carbon has 4, nitrogen has 5, hydrogen has 1. So carbon will make the most number of bonds. It will be in the middle. Now carbon can only bond once with hydrogen, but it needs 3 more bonds. And we know nitrogen needs 3 more bonds. So we put the 3 dots of carbon on the same side with nitrogen. But nitrogen is a total of 5, so it will also have a lone pair on its head. Now, if you look at the shape, the bonds extend in 2 different directions. There is no lone pair on carbon. Therefore, it's going to be linear or 3-atom linear, however you want to call it. Now, if you look at polarity, it's nitrogen on one side, hydrogen on the other side. They are not the same, so the molecule is going to be polar. Now, the name of this compound is boron trifluoride. And boron is one of the exceptions in that it only has 3 valence electrons. And it can only make 3 bonds. It cannot make more than 3. So I see that there are 3 fluorine atoms. Each of the fluorine atoms will go on each side of boron, and it will make 3 bonds. And the shape is there are 3 bond pairs that are extending in 3 different directions. There is no lone pair on boron, so it will be trigonal planar. And the polarity will be non-polar as all 3 of them are fluorine atoms. So we have the next structure for dicarbon tetrahydride, so C2 hydrogen 4. Now carbon again will always be the atom in the middle, but I see that it has 2 carbons, so I'm going to put the 2 carbons in the middle. There are 4 hydrogens. I will divvy up the 4 hydrogens as 2 on each carbon atom. And so my 3 electrons on carbon have paired up, but there is a 4th electron on carbon which is not paired up on each of the carbon atom. This 4th electron on each carbon atom will move to the middle and will make a double bond. So now this molecule actually has 2 shapes around each carbon atom. You should mention this shape around each carbon atom. Now, around carbon 1, we see that there are bonds extending in 3 different directions. So carbon 1 is trigonal planar. Similarly, on carbon 2 also, we see that there are bonds extending in 3 different directions. So that's also going to be trigonal planar. You have to mention 2 different shapes. Even if they're the same, you have to mention it twice. Now the molecule looks very symmetrical, therefore it will be non-polar. Now the given name will be dinitrogen difluoride for the next compound. Now nitrogen has 5 valence electrons, fluorine has 7, so nitrogen will be the atom in the middle. Now nitrogen can make 5 bonds, and nitrogen will bond to itself. Each of the fluorine will bond to nitrogen, and now each of the fluorine will have 7 valence electrons. We should never forget to show the lone pairs on individual atoms. Now nitrogen has 2 more bonds that needs to, 2 more singles that need to pair up. So they will come to the middle and there will be a lone pair on each nitrogen atom. So we have accounted for all the valence electrons in nitrogen. So now again there is nitrogen 1 and nitrogen 2. And if you look, there are 2 bonds extending in 2 different directions, but there is a lone pair also on nitrogen. So nitrogen 1 will have a bent structure. Similarly, nitrogen 2 also will have a bent structure because there are 2 directions. There are bonds in 2 directions and there is a lone pair. Anytime the atoms that are in the middle have lone pairs, the shape automatically becomes polar.